Okay, let's get some practice using some of these prefixes. So for A, we're going to be converting 8.69 times 10 to the fourth. One way you can do this is think about moving the decimal place by essentially 10 to the fourth, or 4 times. So 1, 2, 3, 4. So I'd write this as 869, and then there's going to be a 0 and a 0. For B, it's going to be much the same. 9.1 times 10 to the third. I'm going to move the decimal place 3 times here. 1, 2, 3. So I put a 0, I put a 0. I'll write that as 9100. For C, 8.8 times 10 to the minus 1. So I'm going to put 8.8. Now the minus here means that I move my decimal place in the other direction and move it in that direction. So it's just going to end up right there. So I'm going to end up with 0.88. For D, you can kind of see it's going to be 476. And for E, it's going to be 0.1234. And then I got my 5, and then the 6, 2. Problem number 8 deals with multiplying and keeping into account significant figures. If I look at 3.079 times 10 to the second, that's going to have 1, 2, 3, 4 significant figures there. This one's going to simply have 2 significant figures, so my end result should have 2 significant figures. If you multiply those two together, you get 2.094. I'm measuring something with a unit of meters, or I'm multiplying meters by meters, so the unit for this guy is going to be square meters. Now for the significant figures part of this, I should only have 2 significant figures, so the first 2, but the one that follows it's going to be a 9, so I'm actually going to round it up to 2.1 square meters. Number 9 is a problem that deals with percent uncertainty, remembering that percent uncertainty is going to be essentially be equal to the uncertainty divided by the value. It's asking me what is the percent uncertainty of 1.57 square meters. Well, my uncertainty in this case is going to be 0.01. The value, I forgot my multiply by 100. So that's going to be 0.01 is going to be the uncertainty. The value is 1.57. Multiply that by 100%, and at the end of the day I'm going to come up with 0.637%. However, keeping in mind if I have significant figures, this guy is going to have 1 significant figure, this guy is going to have 3 significant figures, so technically my result should be should have 1 significant figure, or 1%. In reality, after this chapter, I'm perfectly happy to accept 0.637, 0.64, 0.6, or even 1%. Now let's get some practice converting units. We know that the sun is going to be 93 million miles from Earth, so that's 93 times 10 to the 6 miles. I want to go ahead and I want to convert this into meters. So I know that 1 mile is 1609 meters from the front of the book. So I go ahead and I multiply this guy out, which is essentially like multiplying by 1. You can see how the unit of miles is going to cancel out, and I'm going to end up with 1.496 times 10 to the 11th, now with a unit of meters, as you see right here. Now, keeping into account of sig figs, this has 2 significant figures, so technically I should write this as 1.5 times 10 to the 11th meters. Now for part B, it wants me to express that in kilometers, so I have my 1.5 times 10 to the 11th meters. I know that 1 kilometer is going to be 1,000 meters, so I go ahead and I multiply this guy out. I'm going to cancel out my unit of meters, be left with units of kilometers. Essentially I'm dividing by 1,000, and I get 1.5 times 10 to the 8th kilometers. Lastly, we have a little bit of an estimation problem. It says, estimate how long it would take to mow a football field using a standard lawnmower. So, to do this, we're going to say, well, here I have my football field, and the NCAA regulation says that this should be 360 feet long by 160 feet wide. So first thing I need to do, I'm going to work in the metric system. That's going to be essentially roughly 110 meters long by about 50 meters wide. So it's going to have an area which is going to be equal to its length times its width, which is going to be roughly 5,500 square meters. Now what I want to do is I say, well, suppose my lawnmower has a width of 0.5 meters, so I'm going to say, I'm going to chop this guy up, and each one of these stripes is going to have a width of 0.5. That's me essentially walking up and down the field once. The distance that I'm going to need to travel is going to be essentially how many of these guys I have to do. The distance that I need to travel is going to be the area divided by the width of my mower, which I'm going to say is 0.5 meters. So 5,500 square meters divided by my 0.5 meter width tells me that I'm going to actually have to walk 1,100 meters, or really 11 kilometers. So I'm going to have to walk a long way. Now let me just safely assume that my speed is going to be 1 kilometer per hour, as it suggests. So I'm going to be able to walk 1 kilometer in 1 hour. You can kind of see if I take my 11 kilometers and I divide that by my speed, 1 kilometer per hour, the units here of kilometer are going to cancel out, and hour is going to flip up to the top. So it's going to take me 11 hours to mow this football field with a conventional lawn.